Okay, so before you start playing with Arduino or any other such electronic prototyping platform, it is imperative that you know some of the basics of electronics, okay? Now you might be aware of this stuff already or maybe not. If later, then I would highly recommend that you go through this lecture before diving deep. If former, then feel free to skip this section and jump to the next video in the course. Now the first electronic component is battery, which is denoted by a positive and negative sign like this, battery. Now, battery is an energy source which is used to provide power to any electronic device. Now, let me draw a short circuit for you. Here is my battery, positive and negative. Let me connect my positive with the negative, like this, positive, negative. Now, the current in a circuit flows from positive to negative like this, right? Now, this is a short circuit, Now, important thing to note here is that you never need to connect your positive with negative, right? This is absolutely not required. Absolutely not required. This is dangerous. Another thing to note here is that the positive terminal of battery is called cathode and the negative terminal of a battery is called anode. Okay. So let's move on to the ground, the concept of ground. Now let me draw three horizontal lines. This is ground. Now the ground is actually the return path that is required for every circuit to become closed. Simple as that. A lot of people get confused with ground, but that's the simplest explanation of this concept. Every component in a schematic is connected either in series or in parallel or both in the path of positive only. Okay, so ground is common for every component. Okay, so after ground comes resistor. The resistor is a passive electrical component denoted by the zigzag sign, resistor. It has no polarity, which means you can connect it with either side, no polarity. And you need not to be worried about the polarity, okay? A unit of resistance is ohms, which is denoted by this sign just like this. Important thing to note here is that resistors are used in a circuit to limit the current or divide the voltage to specific components in the circuit. Okay. Let's take a look at LED, which is a short form for light emitting diode. It has a positive and negative polarity, light emitting diode. Now, a light emitting diode is a two-lead semiconductor light source. It is a PN junction diode which emits light when activated, okay? Like I said, it has a positive and negative leg, and because this LED emits the light, and that's one of the reasons why two arrows are pointing away from the LED, just to show that this is a light emitting diode. It's emitting the light when a light is thrown on it. After LED, let's turn to a switch. Okay. Let's turn to a switch, which is also called a push button. So some people call it push button as well, or you can call it push button as well. Or here is a push button. Okay, push button. Now you can use it to make or break any electronic circuit. Simple as that. Now let's turn to something more exciting. Let's make a series circuit. So let me draw this first for you. Just a second. Let's say we have three resistors in a circuit that are connected with the battery like I have drawn here, alright. Three resistors, R1, R or R, so positive and negative. Now R here is resistance, and I, which I am going to denote in blue, is the current, okay, which is flowing from positive to negative. I is current. Now the current should flow from positive to negative terminal as we discussed shortly before, right? I should flow from positive terminal to negative terminal. Just like this. Just like this, from positive to negative. Right? Now this circuit is a series circuit. Why? Because the current I has only one path to flow from it. Isn't it? That's why you call it a series circuit. Right? I has only one path. Now an important thing to note in a series circuit is that the value of current remains same while the value of voltage divides by the value of resistance using Ohm's law. Okay. Series circuit. Now let's see how a parallel circuit is different from this one. Okay, so let me draw a parallel circuit for you. Just a second. Just a second. So positive and negative. So this is R, this is R. This is also R. Now R here is as usual the value of resistance. The value of current is also as usual I. Now I'm using blue color to denote the current, okay. I as a current. Now here, this is a point which is called a node, okay, a point where two or more circuit elements meet. That point is called a node, so we have three nodes here, right. As you can see, there are three different currents flowing through, right, I1, I2 and I3. So there are three different loops. I1, let's say the current flowing through this second loop is I2, and let's say the current flowing through this third loop is I3, okay. Now I call this circuit a parallel one because current has three paths to flow and not just one, okay. See here, there are three paths. I has more than one path, right. Now important okay. So now the important thing to notice here is that in a parallel circuit, the voltage at each node would remain the same while the current would be divided, right. This is just a basic overview of the series and parallel circuit, which is important to understand before start making projects on Arduino board. So let's move on to the second video.